Hello there, students. Today we will learn about DeMoivre's theorem and use it to obtain some double angle formulas in an example. DeMoivre's theorem states that cosine theta plus I sine theta raised to the nth power is equal to cosine of n times theta plus I sine of n times theta. This theorem can be useful in deriving any number of multiple angle formulas. For instance, for n equals 2, we find the following. Expanding the squared term on the left-hand side, remember that I is defined as the square root of -1, so I squared is equal to -1, which is why the sine squared term on the left side is negative. From this result, we can look at just the real parts, meaning the parts that aren't multiplied by an I. From the left side, we have cosine squared minus sine squared, and this is equal to the real part of the right side, which is just cosine of 2 theta. This gives us a double angle formula for cosine. We can do the same thing for the imaginary parts, or the parts that are multiplied by an I. From the left side, we have 2 sine theta times cosine theta, and this is equal to the imaginary part of the right side, which is sine of 2 theta. This gives us a double angle formula for sine. Euler's formula says that e to the I theta is equal to the cosine of theta plus I sine of theta. This looks pretty similar to the left side of DeMoivre's theorem. We can raise both sides of Euler's formula to the nth power to make this equivalent. This means we can combine DeMoivre's theorem with Euler's formula, giving us the ability to use exponentials when appropriate in our works.